Welcome to another great video. Now on this one we have this past paper problem from, it's a common test paper, March 2020. So the reason I want us to focus on this one is some people get stuck when they are given a problem like this where the force is applied in this fashion instead of, because usually we're used to it being applied somewhere here and then there's an angle there, but when you check that one, it's applied in a different way. Right, so I want us to focus on this one and let's see how we would tackle a problem like this. So let's just read. We have two blocks, A and B. These are connected by a string of negligible mass. Then the mass of A is 4 kilograms and the mass of B is 2 kilograms. Okay, now block B is pushed by this force Z, or as the Americans would say Z, but let's say Z, of 40 newtons acting at an angle of 30 degrees to the horizontal. Okay, so if you remember our rule of thumb, as soon as you see a 2D vector, which in this case our vector Z is a 2D vector, it means it deserves to have components. So it will have ZY and it will have component ZX like this. We usually draw components from the tail of the vector, right? Something like that. That should be ZX. And then when obviously now you want to find the trigonometric relation of each vector, or of each vector component to the, let's do this, to that vector itself, then now you can draw these components in this fashion so that it forms a triangle. Okay, so now we have this right angle triangle and then we have an angle of 30 degrees here. So this is our ZX. Then from here we can sort of start finding what ZX and ZY is respectively. So say this is ZY. Right, so we have this. These are the things that we have. Now let's continue reading. So the coefficient of kinetic friction between block B and the horizontal surface is 0.25. Okay, and then block A experiences a frictional force of 9.8 newtons. All right, so for block B we have mu K. Let's use this guy. We have mu K being 0.25. okay, that's for block B. And then for block A, instead of giving us a coefficient of kinetic friction, they gave us the magnitude of the kinetic friction itself. So we are fine there. We know that for A, our FK here would be 9.8. right, so in an event where, now imagine if they only said the coefficient of kinetic friction experienced by block B is 0.25 and they don't give us the friction of A, we would have to assume that this coefficient, since these blocks are on the same surface, so it's therefore applicable to both A and B. Okay, but in this case they did give us the magnitude of the kinetic friction, so we don't have to worry about that for now. All right, so now we have pretty much everything we need. So let me take this guy and just write it here. These are big enough so I can just write it here. So what I usually like to do is, before I even start answering the question, I want to annotate my forces. So let's say, obviously, there's a normal force here because this block is in contact with the surface. And then the normal force is always perpendicular. Then we have kinetic friction here. So kinetic friction, which is Fk, is 9.8 newtons. And then we have tension going that way. Okay, so, and lastly we should have weight, or Fg, weight W or Fg. So some people prefer Fg, it's the same thing really. And then we have these forces now. Let me use a different color. We have another set of forces here. We have tension going this way. So one of the reasons these tensions are always opposite to one another is due to Newton's third law. Right. So it is actually due to Newton's third law. Now let's check. We have then we have that force Z, and then we have a normal force here, N or Fn. Then we have weight or Fg. It's up to you, or it's up to what your teacher prefers. I just prefer W. And then we have friction going that way as well, Fk. All right, so these are all the forces that we have. Okay, my N it doesn't look very much perpendicular, but just assume it's perpendicular because it has to be. And when you draw it, make sure it looks perpendicular on your side. Okay, and now we are coming to 4.1. Draw a free body diagram to show all the forces acting on the 2 kilogram block. Okay, so for the 2 kilogram block, we've already annotated that block, so it shouldn't be an issue to draw our free body diagram because we'll just copy there. All right, so let's start with the normal force. It's N going up, followed by my weight. It's W or W. And then we have tension. Then we have Fk. Notice I make my Fk smaller than my tension. And then we have that applied force Z. So most people, when they get to this one, they find it confusing on how to do it. So if you notice our free body diagrams, all of them, we make sure that the force originates from the dots. So the tail of the force, or the tail of that vector representing that force, is starting from the dots. So what that means is you cannot draw Z like this and then have an arrow here and then call this Z. This is not allowed. You can't do this, right? Maybe later on in life you can, but the rules for now don't allow you to do this. So what do? We know that since it has to be at the tail, let me write Z here. You simply just move this thing along this line, right? So it has to be starting here and going there instead. It's still the same force. You haven't changed anything. And then you're just making sure that you connect the tail of the force to the dots instead of the head of the force to the dots. So we will take this and we will move it here. That's all it takes, right? So in an event where now they say also introduce the angle of the force, you can put it here, but the only difference now is the one that we were given was here, which was, I think, or which is 30 degrees. Now it does not mean that you can just simply go and put 30 degrees here. It doesn't work like that because the given angle was here. So if you know your right angle triangle, you will know that if you have 30 here, so just because the vector was here, if you think about that angle, I mean, we said we're drawing our vectors like this, right? Where this is your zx, this is your zy, and this is your z. And then we are given 30 degrees here. And then this obviously is a right angle triangle. It always is. And then you would have to find this guy, which you just sum of angles in a triangle is 180, and you will find this angle to be 60. So in an event where the instruction says you must also put the angle there, we usually put it here, and in this case it would be 60 degrees. Then you would put it there, but in this case it was not required for you to do that, so you'll just leave the free body diagram as it is. Okay, yeah, that's what you would do. So now, my W looks like Z. So now that's our free body diagram, and if you count the forces, you must have the same number of forces as these marks, unless if there was an extra instruction. But in this one, it was simply asking for you to just draw a free body diagram with all the forces. So you know that you must have 5 forces there, because this question is worth 5 marks. So that's it. And then we can now go to 4.2. In 4.2, we are required to find the magnitude of the vertical component of the magnitude of the kinetic frictional force experienced by block B, given that the vertical component of force Z is 20. So they are telling us that Zy is 20 newtons, right? Zy is 20 newtons. Now we are asked to find the magnitude of the kinetic frictional force experienced by block B. We know that the frictional force is mu k times n. We've already been given mu k, but we do not know what n is. So let's find n. My rule of thumb is simple. Whenever you find n, you take the sum of forces acting perpendicular to the surface of that block, or perpendicular to that block. In this case it's a block, but I don't like limiting it to a block because it can be another object. So all perpendicular forces, you take that and then you make n the subject and solve for it, because sometimes n is not simply, most people just come and say n is w. Some, they know that once you introduce an applied force, you have to then subtract the vertical component of the force, right? But they don't know where all of this comes from. So I'm telling you, it comes from this. You come and say Fnet is equals to naught. The reason it's not, because the block is not moving along the vertical axis, it's only moving horizontally. And you take up as positive. The reason we do that is because n is going up, so we want n to be positive. You could take down, it doesn't matter, but at the end you'd have to multiply by a negative sign, which you don't need that. So you'll have n plus minus weight, because weight is going down, plus minus your zy, because zy is also going down. So you take a sum of all these forces and the respective components where applicable. Sometimes you'll only have weight, sometimes you'll only have sometimes you'll have both weight and an applied force, and therefore that applied force, if it's at an angle, it will introduce a vertical component that you have to account for, you have to include when calculating your n. So from here, this is where n becomes weight plus zy. Okay, my bad. So you see, in this case, it was not weight minus zy, it was weight plus zy. But you wouldn't have been able to tell if you don't know where that whole expression of n, or that whole equation of n, comes from. Right, then from here we can put your mg if you want, but you can just substitute straight from here. We are given z, ne? Yeah, let's just substitute. We know that weight is simply, is it the 2 kilogram block? What block is this? Block B, that's 2 kilograms. Is mg, which is 2 times the constant, which is 9.8, plus 20. That should be 36 point something. Let's see. 2 times 9.8, 39.6. Oh, yeah. 39 9.6 newtons. That's your N. Okay, now obviously if you can look at your diagram and immediately extract this equation of N, that's okay, because you won't get marks for doing this. You will only get marks for this part of it. Okay, so this is just to make sure that you understand where this thing is coming from, and by virtue of you understanding where it comes from, you can then be able to calculate N in any given scenario, okay, without memorizing, because that's all that matters in physics, maths, and most STEM subjects. You have to understand why we're doing certain things. Okay, now let's find our Fk. So we said Fk is simply mu k times N. Then we are told that mu k is 0.25, and then our N, we just found it to be 39.6, and then from here times 0.25, I get that my frictional force is 9.9 newtons. That's it. That's how you would have done this part of the equation. So the frictional force experienced by block B is about 0.1 newtons higher than the one experienced by block A. That's interesting. And then now we are asked to find the magnitude of the tension T in this string by applying Newton's second law of motion separately to each of the blocks. All right, so here in these types of questions I usually introduce two methods, but following instructions is very, very much crucial. So they even put it in big words for you, in caps or capital letters and so on, separately to each block. This means the method one that I normally use is the only one that you will use here, because it involves calculating, or it involves separating these blocks and then calculating independently, and then solving using simultaneous equations where necessary. Sometimes they're not necessary. Okay, so that's the method that they want here. Then in method 2, remember what we would do. We would calculate, but we would take these blocks as a unit. We take it as one thing. But then in method 2, it wouldn't work, because method 2 means when we sum our forces, this T won't be part of those forces. So it makes sense why they had to guide you here and say use that method where you have to do it separately. So let's do it. We can start with block. Let's start with block A. Let's go alphabetically. Block A, and you do tell us that I'm focusing on block A for now, otherwise how will we know? And then you say Fnet is equals to MA. Then now you have to choose a direction. I will take my right as positive because the blocks are going to the right. You can write it in words or in symbols. I prefer symbols, they save time for me. And then block A has tension, which is positive because it's going to the right, plus it only has friction in the opposite direction. Then we say MA. Then from here we can substitute. We have T minus 9.8 is equals to 4A. We don't have A. Let's see. They didn't say these things are moving at a constant velocity, so we can't say A is 0. And they didn't give us a value for A, so we leave it as it is. Then from here we can make A the subject. Why do we make A the subject? Because we are solving for T. So we make the one that we do not want to solve for, we make it the subject of the formula, and the one that we want to solve for, we don't make it a subject. So obviously when you're solving simultaneous equations, which in this case we are likely to use simultaneous equations here, you have to is it? Let's check. If I started with block B, I would have FK, T, and ZY. I would easily solve for T. Okay, it's fine. Let's start with block B. Sorry about that. We don't need simultaneous. I just noticed now. Block B. This is one of the things you'd see in your exam. Sometimes you'll have to redo some other calculations, especially if you make mistakes. So let's start with block B. I'm choosing right as positive still. And then all horizontal forces, I have Zx, it's positive, plus my tension will be negative, plus my friction will definitely be negative as well. And all of this is equals to MA. Okay. Oh, I forgot we don't have A, so it doesn't matter which block we start with. Sorry about that. Anyways, let's continue using this one. It's fine. So Zx is simply 40 cos 30, right? Minus T minus 9.9 is equals to 2A. Good. So yeah, we can take that, and then from here I'll just write the final tension that we have, the final equation. So this will be 24.74 minus T. This will give you 2A. Okay, so you can either choose to make this equation 1 from this point, but when you get to the point where you have to solve for T, you'll have to do some serious manipulation there. So what I usually prefer is just make the one that you don't want to solve for, you make it a subject. So meaning for me, I would divide by 2 and divide by 2 this side, and then I would say A is 24.74 minus T, all this over 2. So I can call this my equation 1. Some people prefer the line to be dotted. It's okay, you can do this. So that's equation 1. Then we can go to block A. For block A, we do the same thing. Fnet is equals to MA. I'm taking right as positive, and then we have T plus, we only have friction going to the left, and then we take this and we make it MA. Then from here we can say T minus 9 point, what did we do here? Okay, it's 9.8 is equals to 4A. Right. From here, you can easily say divide by 4, then you have A being T minus 9.8 over 4. These fractions shouldn't scare you. You are doing maths. So when you see a fraction like this, you should know that it's not an issue. I will solve for it. So now when you get to this point, this is where you can just say A, or equation 1 is equals to equation 2, right? Then you take these equations and you put them alongside each other. Let's take this one, and then at this point you'll be able to solve for your T. T is equals to T minus 9.8 over 4. Here it's just math. So I would say times 4 over 1 times 4 over 1, both sides, and then this gets rid of that. Then here this will be gone. You'll be left with a 2 here. Then that's 2 times 24.74 minus t. You don't get marked for these manipulations. They only want some of the steps and your final answer. That's why it's 5 marks. This they expect you to know from maths. So from here, I'll just write my final answer, but it's fine. Let's do 24.74 times 2. That's 49.48, okay? Minus t is equals to t minus 9.8. And then from here, you can take t this side or that side. So you can say plus t. Then this t will get rid of that t. And then on the right hand side, you'll have 2t. And then you can bring 9.8 this side as well. So you'll have 49.48 plus 9.8. And then you'll have 2t that side. It's just maths, guys. And then your final answer will be t is equals to, you take all of this, 49.48 plus 9.8, you divide it by 2, because you have to divide by 2 both sides. Right, and then you get your answer. 49.48 plus 9.8, you get 2. You divide by 2, and then you get that your t is 29.64 newtons. That's how you would do this 5-mark question. On the other hand, what you could have done is, if you understand that there are different ways to solve simultaneous equations, right? Another way you could have done this, when you got to this part, you could have taken this guy. Let's say this is our equation 1. Let's come here, paste. So this was gonna be equation 1, right? This is our equation 1, I mean. And then we take equation 2. Where's our equation 2? Take this one as our equation 2, just for the guys that prefer multiple ways of doing things. Because at this point, once you get to this point, it's all maths, guys. You don't have to overthink it. You have done half, if not 80% of the job. So all you need to do now is apply your math skills, right? And it's not that intense with the mathematics as well. It's just 2 equations, okay? So what you could have done is, if you remember in simultaneous equations, you can manipulate certain values such that they look alike and then subtract the equations. Let me show you what I mean. So you want to get rid of the a, right? So if I say 2a, or actually if I say 4a minus 2a, I will get 2a, right? But I want this to be 0. So what you could have done also is, you can manipulate this, multiply this whole equation by 2. So multiply equation 1 by 2, which will give you a new equation. Your new equation would be, I think it's we said it, this is 49. What is it? 48. What was that thing? 49.48, yes. Minus 2t is equals to 4a, right? And then that's our new equation 1. Let me change its color. That's our new equation. We can even call it equation 3, really. Yeah, let's call it equation 3. It's fine. Equation 3 doesn't sound right. It's our new equation 1. So if you check now, these 2 are matching. But so if they are matching, it means if I say equation 2 or equation 1, doesn't matter which one you start with, minus equation 1, these guys will go away because they will subtract each other, and it will be 0 on the right hand side. The reason we can do this, it's perfectly fine. It's one of the ways you can solve for simultaneous equations mathematically. So that's another way you could have done it. So what you will get here is, let's see if it works. You'll have, it will be equation 2 minus 1 Let's see. So let's start with the right hand side. We will have t minus 9.8, right? Minus, because we said 2 minus 1, 49.48, okay, minus 2t. And then we'll have 4a minus 4a. So these ones will just go away. Yes, so we have it like this. Then you know that you can take t minus 9.8 minus 49.48 plus 2t is equal to 0. So at this point you can have 3t because this is t plus that. And then when you add these two and transpose, okay, let's do it step by step. So it's 9.8 plus 49.8 because it's minus minus anyway. Then you'll have 59.6 is that. Then when you transpose, take this side there. We call this transposing. Right, you'll have t simply being 59.6 divided by 3, which should give you 19.87 newtons. Let's check if it matches our answer before. That's your answer if you use this method. Let's say or. So it's up to you which one you prefer. So we got 19.87 here, but we got 29.64 here. So it means one of our operations has a mistake. I doubt it's the second one. So let's check this one. Mistakes are everywhere, guys. Don't worry. Don't panic. Oh, yes, I see something here. So when we were multiplying here with 2, we did this one correctly. But when we're multiplying the t, we forgot to put the 2 here. So this was supposed to be 2t. So this changes a lot of things because it means now I was supposed to subtract t there. And then what I do on the left, what I do on the right, I must do on the left, minus t as well here, plus. So this will get rid of the t on the left. And then I'll be left with minus 3t on the right. So this means I was supposed to have minus 3t, and then I was supposed to divide by minus 3 here. This was supposed to be like this, and then let's see if we get the same answer. Minus 49.48 minus 9.8 minus 3. Yes. I get 19.87. That's what we should be getting. So, yes, guys, that's all we had to do for this one. No. Why am I making so many mistakes? I get 19.76 newtons. So this guy is supposed to be 49.48, 59.28. Sorry guys, I don't know what's happening with my calculations today. So yeah, now it's fine. Everything is fine now. It happens, okay? So that's all you had to do for this problem. Thank you very much. I will catch you on the next video.